Hello, here's the report for Lab 1, where I calculate the amount of excess charge on an ordinary object. Let's look at the goals and concepts covered in this lab. Let's understand the concepts of electric charge interactions with other charges, as well as electric charge interactions with neutrally charged everyday objects. Concepts involved in this lab are Coulomb's law and basic understanding of forces. Let's look at the hypothesis I had while conducting the experiment. What did I expect to be the interaction between the two U-tapes? I expected them to repel simply because I expected them to have the same charge, which would mean that like charges repel. And how do you expect them to interact with other objects? I expected them to be attracted to neutrally charged objects such as books, tables, fingers, simply because I expected them to be charged, and a charged object creates a dipole in neutrally charged objects, which would in turn cause a force of attraction. Looking at the empirical results, first thing that we can notice is that both of my hypotheses turned out to be correct, such as the two U-tapes repelled when they were brought close to each other, and the U-tapes attracted when they were brought close to a neutrally charged object. Additionally, using the plastic pen test, I determined that the U-tape is positively charged and the bottom tape must therefore be negatively charged. Now, the experiment was set up as per the instructions described in the lab manual, and the length of the tapes used was fixed to be 10 centimeters. The distance at which the tape started to float was calculated to be approximately 1.2 plus minus 0.3 centimeters. These readings were taken 3 times using different tapes of the same length and type. Let's look at the source of experimental error. In such a complicated experiment, there can be multiple sources of experimental error, namely parallax error and the fact that the humidity and temperature of the room weren't controlled, the tape variety and brand wasn't considered, and the charge might have been grounded at several occasions due to contact with the skin. And also the fact that estimation was used to see when tape B was floating. To counteract this, multiple readings were taken and the room was kept under air conditioning. To approach this problem, I first started off by defining the constants that were firstly derived experimentally and secondly are universally known constants. Then I created a simplified version of this problem by modeling both the tapes as point charges, which are depicted as spheres in VPython. And then I visualized this to be something like this. Then I defined a function that can calculate the force due to gravity based on the mass of the tape, which was calculated using the given information. The clear tape has a mass of about 1 gram per meter. Then I put in functions to calculate the charge and the number of deficient electrons. The charge was calculated to be approximately negative 1.28 into 10 to the negative 9 coulomb. And based on this and the elementary charge of an electron, it was estimated that 8 into 10 to the 9 electrons were deficient from the side of the tape. Now, calculating the percentage of atoms that lost electrons, we essentially use the sticky side of the surface, and we assume that it is a two-dimensional surface, and we approximate the number of atoms to be 2.5 into 10 to the 17th. And based on this and the number of electrons lost, we calculated the percentage of atoms that lost electrons to be approximately 3.2 into 10 to the negative 6%. Here you can have a look at the simulation code that was used to create this visual as well as used to calculate the various values. Addressing the questions that were ascribed to us in this video, what if the electrons had positive charge and protons had negative charge, and what would change about this particular scenario? Essentially, nothing would change as charges are only important relative to each other, such that like charges attract and unlike charges repel. And antimatter, as a factor of trivia, is expected to behave this way. It is expected to mirror the laws of the matter universe, except electrons would have a positive charge and protons would have a negative charge. Why is it important to handle the charged tapes as little as possible? What happens when charged tapes come into contact with your hands or other objects? Now, what happens is that the charge diffuses over the new larger bodies. Essentially, when you touch the tape, it diffuses the charge from the tape onto your entire body, leaving less on the object of interest, that is the tape. And this reduces the charge on the tape to effectively zero, so less that it is almost insignificant. Thank you.